Okay, Year 13, let's do a quick recap of normalisation in databases. So there are three normal forms that you need to be familiar with. First normal form, second normal form, and third normal form. I've got an example here of some A-level grades for students, and on the top left I have this is not normalised at all, and down here the data has been normalised into first normal form. The main requirement, the requirement of first normal form, is that all values must be atomic. So let's have a look at this table up here and kind of see what's going on. So I can see that the student Joe, who is 15, these are atomic values, there's just one value in each cell. He studies two subjects. In maths, he got an A, and in computer science, he got a B. Certainly not my grades. So that's what he's got there. Now, these values here are not atomic because there are multiple values in each cell, and you can see that this structure goes all the way down. So Jim here does maths, further maths, mega maths and ninja maths, and he has 4 grades accordingly. So I don't even know what that's supposed to be, but the idea is that there are the same number of grades as there are subjects, but these are not atomic. And so how do we solve that? Now, the solution is probably going to look a bit messy because first normal form is not normally where you would stop, but just purely fixing first normal form, what I'm going to do for each row here is make a row for each subject and grade combination. So I'm going to have a row for Joe where he studies maths and he got an A, and another row where he studies computer science and got a B, and you will see that that one row there is becoming those 2 rows there, and that's basically what we've got to do all the way down. Okay, so I've just shown Joe and Steve here. So Steve, who he studies 3 subjects, maths, physics and drama, interesting combination, and so he's got now 3 rows in the table. I'll perhaps do that in a different colour. So Steve here has 3 rows in the table, 1 for each subject, and now the values are atomic. So this is in first normal form. Stepping across to second normal form. Now, I've changed the table slightly. Whilst you do kind of go through them in order, it can be quite hard and quite contrived to get one example to kind of require work at each step. So this table on the top left is not obeying second normal form, and the bottom right here is, and we're going to explain why. But first, I just need to talk about the structure of this table. So here I've got a student ID and a subject, and those together are a composite key. And as soon as you've got a composite key, you can only really have violations of second normal form if you have a composite key, because the whole thing with second normal form is you are removing partial key dependencies. So what do I mean by that? Well, let's look at the predicted grade. The predicted grade is dependent on the combination of the student and the subject. Okay, so student 1 has one predicted grade for this subject. He has a different predicted grade for the other subject. I know the values are the same, but let's have a look at the Ted here. He's got an A, predicted an A for maths, a C for chemistry, and an A star for French. The grade is dependent on both of these things. Because, yeah, so I think you can see that. But this field here, the student name, it has no bearing, it is not dependent on the subject in any way. So Jim is called Jim in maths, and he's also called Jim when he turns up for English. Ted is called Ted by his maths teacher and his chemistry teacher and his French teacher. So really, the student name only depends, and let's do this on here, only depends on the student ID. So the name depends on ID. ID is only part of the key. It is not the whole key. So how do we solve that? This is where we start to break things up into multiple tables. So I have one table on the top left here, and I'm actually going to break it up into 2 tables. So where I've identified that partial key relationship, I'm going to pull that field out and make a new table with only that key that it depends on. And you can see that's what's happened here. So I have a table here of students that just relates the ID and the name. So Jim is student 1, Ted is student 2, Chloe is student 3. And then my original table no longer needs to tell me what the name of the student is. And you can see actually that the benefit here is I was repeating this data here, and now I'm not repeating that information. So Ted is student 2. I'm removing redundancy. And that is one of the key things that we're trying to achieve with normalization, is to remove redundancy. And this will also help consistency. So if I went through and renamed Ted to like Teddy, I'd have to remember to do that like 3 times up here in the top left, because it appears 3 times. Now I can just do it once. So it's going to help me be consistent. It's going to remove redundancy. But second normal form is partial key dependencies. And I think the key confusion is the difference between second normal form and third normal form. So I kind of just think of it as like getting, it's like your partial key, and then the next one, well, we'll see when we get to the next one. Third normal form is about removing non-key dependencies. So it's kind of nothing to do with the key now. This is where you have fields that relate to each other. Again, this is a whole new example, because examples that any example you get, if you solve second normal form, you often solve third normal form at the same time. That quite often happens, unless the example is non-trivial. So this is a new one about doctor appointments. The primary key here is just a single field. In this case, it's the primary key. It's just the appointment ID. And the appointment ID has a time, so the time is completely related to the appointment. That's fine. The doctor is completely dependent on the appointment. That's fine. There cannot be any partial key dependencies here, because the key is only one field. So you can only have partial key dependencies if you've got a composite key. Patient name. So yeah, each appointment needs to know which patient it's on, and that's completely dependent. But here is where it gets a bit sticky. So the patient address is really dependent on the name. Okay, so the address depends on name. Name is not the key. It's not part of the key in any way. So this is a non-key dependency. And you can see that this manifests in duplicate data. Duplication. So this, again, we're removing redundancy, which is why second normal form and third normal form, they look really similar to each other. But third normal form is this non-key dependency. So maybe that would slip through the net when you did the second normal form, but it would have to be a more complicated table. So the solution to this is basically the same as the solution to second normal form, in that you make a new table that expresses that relationship. And so that is, these 2 fields now become this table down here. So instead of me being told twice that Mr. Ree, actually I have not put him in there, lives in 4 Blue Lane, I'm going to be told that once in this table now, rather than every time Mr. Ree actually makes an appointment. And then in my original appointments thing, I remove the field that had the partial dependencies. The address is gone now. So the solutions to second normal form and third normal form are basically the same. It is the nature of the field it's being dependent on that is different. In second normal form, the field that's being dependent on is part of the key, and we want to remove partial key. In third normal form, the field that's being depended on is a not part of the key. It's a non-key dependency, and that needs to go. It's all about removing redundancy, increasing consistency, and that's basically what normalisation is all about. There are other normal forms that people talk about, but these are the main 3 that you have to know for the A-level. These are the only ones you have to know for the A-level.